Space is mostly silent, so when something speaks, scientists listen. Over the past few decades, we've detected signals from space that don't match anything we understand. Some appeared once, some repeat, and some are still active today. These signals didn't come from planets, they didn't come from stars behaving normally, and to this day, we don't know exactly what caused them. In this video, we'll look at 3 of the most mysterious signals ever detected from space, and why none of them have a confirmed explanation. Not theories, not speculation, just the facts and the unanswered questions around them. Space is full of noise. Stars emit radiation. Galaxies glow across the electromagnetic spectrum. But scientists aren't listening for noise. They're listening for patterns. Using massive radio telescopes, we scan the sky for signals that stand out, signals that appear artificial, or at least unnatural. And once in a while, something shows up that doesn't fit any known category. The 3 signals you're about to see are among the most puzzling ever recorded. In August of 1977, a radio telescope at Ohio State University was quietly scanning the sky. Then, for 72 seconds, something happened. The telescope detected a strong, narrowband radio signal coming from the direction of the constellation Sagittarius. It wasn't random. It wasn't static. It matched the exact frequency scientists expected if an artificial signal were ever sent. The astronomer reviewing the data, Jerry Eman, circled the signal and wrote a single word next to it. Wow. That's how it got its name. The signal was so precise, so unusual, that it immediately raised serious questions. But here's the unsettling part. Scientists pointed the telescope back at the same region of space, again and again. The signal never returned. No satellites were found to match it, no aircraft, no known natural source. To this day, the wow signal remains unexplained, a single powerful transmission, heard once and never again. For years, scientists thought the wow signal was a one-time mystery. Then, in the early 2000s, something even stranger appeared. Fast radio bursts, or FRBS, are incredibly short pulses of radio energy. They last just milliseconds. But in that tiny moment, they release more energy than the sun produces in days. These signals come from distant galaxies, millions or even billions of light years away. At first, scientists thought they were glitches, but they kept happening. And then, something changed. Some FRBS began to repeat. That's a problem, because most known cosmic explosions, like supernovae, happen once. Repeating FRBs suggest a source that survives and keeps transmitting. One leading explanation involves magnetars, ultra-dense neutron stars with extreme magnetic fields. But even magnetars don't fully explain the precision, strength, and repetition patterns we're seeing. If these signals are natural, they represent physics we don't fully understand yet. In 2015, astronomers studying data from the Kepler Space Telescope noticed something unusual. A star, officially named KIC 8462852, was behaving strangely. Its brightness dropped, not slightly, not regularly, sometimes by over 20%. Normal stars dim in predictable ways when planets pass in front of them. This wasn't predictable. The dips had no clear pattern, no clear size, no clear timing. Some scientists briefly considered an extreme possibility. A massive structure orbiting the star, blocking its light. The idea was quickly challenged, and no evidence confirmed it. But even today, the behavior of Tabby's star remains unusual. Dust clouds? Maybe. Comet fragments? Possibly. A definitive answer? Still missing. Whatever is happening there, it's not behaving like a normal star. The universe constantly sends us information. Most of it makes sense, but sometimes it doesn't. The wow signal, fast radio bursts, Tabby's star, each one reminds us of the same truth. Our understanding of the universe is incomplete, and maybe that's not a flaw. Maybe it's an invitation. Because somewhere out there, something is still sending a signal, and we're still listening.